Match problem 3 is still going to be applying these basic integral properties and formulas that we've established. But in order to apply them, we're going to have to rework our given problems a little bit to make sure our formulas match up. So the beginning of this isn't a problem. We have the integral of 2x to the 2/3 and then minus 3 over x to the 4th. We don't have any rule that applies to x being in the denominator unless it's just 1 over x. So what we'll do is rewrite this as 3x to the negative 4th dx. So now what we have is x to the nth power. Since that's not negative 1, we can still just integrate it by increasing the exponent by 1 and dividing by that exact same result. So we could also take the steps to rewrite this by breaking up that integral over each of the terms, setting that constant factor aside, but we're going to skip through a couple of those steps. We'll just write this as 2 times x. We're adding 1 to that exponent, so that's going to be x to the 5/3, and then divide by that exact same amount, minus 3 times x. Adding 1 to negative 4 is going to give us negative 3 over negative 3 plus some constant c. So that's going to be 2x to the 5/3. Dividing by 5/3 is the same thing as multiplying by 3/5. 3 over negative 3 is going to cancel and leave us with negative 1, so our two negatives will cancel out to give us plus x to the negative 3rd plus c, or 6x to the 5/3 over 5 plus 1 over x cubed plus c. So writing this as x to the negative 3 or 1 over x cubed are exactly equivalent statements. For an exam, I'm fine with either, but the MLP homework tends to be picky about having things written without negative exponents. In part B, we have the integral of 4 times the 5th root of w cubed. So here we could rewrite this as the integral of 4 times w, and then since we're taking w cubed, and then the 5th root of that, w to the 3/5 power dw, or integrate with respect to w. So again, our exponent here is not negative 1, so we can just apply that basic power rule. So this is going to give us 4 times w to the 3/5 power, increasing that by 1, gives us 8/5. And then we're dividing by that exact same value. So divided by 8/5 plus some constant c. So that's exactly the same thing as 4 times w to the 8/5 times 5 over 8 plus c. Then 4 over 8 will reduce, giving us 5w to the 8/5 over 2 plus some constant c. Part C is a little bit different than what we've seen before, because now we still have the sum or difference of two different terms, two different power functions, but we're also dividing by x squared. So before we can look at breaking up the integration, the first thing we want to do is break this into the sum of two different fractions. So since x to the 4th minus 8x cubed is over this single term denominator, we could rewrite this as x to the 4th over x squared minus 8x cubed over x squared dx. So the integral of this expression dx, because if we perform that subtraction, we could combine these over that same common denominator, get back to our original problem. So we can reduce a little bit here. X to the 4th over x squared gives us x squared minus 8x dx. So we started off with a rather complicated problem. By rewriting it, simplifying, now we're just integrating two relatively simple functions. So we'll get x cubed over 3 minus 8x squared over 2 plus some constant c, or x cubed over 3 minus 4x squared plus c. So whenever we see these more complicated expressions, again, the best thing to do is first try to see, can we just rewrite it in a more simple fashion using power rules or some other form. So here what we have is the integral of 8 times the cube root of x. So that could be rewritten as 8 times x to the 1/3 power minus 6 divided by the square root of x is the same thing as 6 over x to the 1/2. So we've got 6 to the negative 1/2 dx. So again, neither of our exponents are exactly equal to -1, meaning we can integrate these using that same formula that we have for integrating x to the n power. So we'll get 8 times x to the 4/3 divided by 4/3 minus 6 times x to the positive 1/2 divided by 1/2 plus c, which will be 8x to the 4/3 times 3 over 4 minus 6x to the 1/2 times 2 over 1 plus c. 8 over 4 will reduce to 2, so we'll get 2 times 3, which is 6x to the 4/3 minus 12x to the 1/2, or 12 times the square root of x, we could write that either way, plus some constant c. Now in part E, what we have is, again, that rule that I mentioned we have to look out for. We have the product of one function x squared minus 2 times x plus 3. We can't just integrate the first expression times the integral of the second expression. So what we'll do is just expand this out. So x squared times x will give us x cubed. The outside terms, x squared times 3, will give us plus 3x squared times plus the inside terms will give us minus 2x. And then multiplying the last two terms together will give us -6 dx. So we can't integrate the product of two functions. So in this case, what we'll do is just expand that out. And now we can integrate term by term, since these are all being added and subtracted from each other, to get x to the 4th over 4 plus 3x cubed over 3 minus 2x squared over 2 minus the integral of any constant is just that constant times x, plus, again, this constant c, that unknown value. So reducing and simplifying here, this will give us x to the 4th over 4 plus x cubed minus x squared minus 6x plus c.